bitwise OR and exclusive OR operator and ones complement operator, left shift and right shift. These are the operators we will use for representing bit level, for representing the data at bit level, for testing the data at bit level. Okay. These operators are not applicable to the floating point of data or double type of data. It can be applicable to only integer type of data. So what is a bit? Already I said this one. Okay. These are the bitwise operators. We are going to use bitwise AND operator. Yeah, AND is nothing but single AND. Okay. Already I explained the logic of bitwise AND operator. If the two conditions are true, then only the outcome of this operation will be true. The condition 1 and condition 2 are true here, so then the output of this operation is true. So logical operators are nothing but it's a combination of relational operators. Okay. R is nothing but if any one of the condition is true, then the bitwise OR operator can give the true value. So all of you see here. So any one of the condition, in this case the first one is false and second condition is true, then the logical OR operator gives the true value. And similarly, in this case the first condition is true, then second condition is false, then the output will become true. Okay. So XOR, this is nothing but XOR operator. So the output of this XOR operator is 1 when either of the condition is true. Either of the condition is true, then it will give the result true. Here first condition is false, but second condition is true, then the output will be true. So here the first condition is true, the first expression gives the true value, then the second expression gives the false value. In this case also it gives the true value. This is the XOR operator. So these are bitwise logical operators. We are used to represent data at bit level. Okay, now we will see how the bitwise AND operator is used. So here we need two operands to perform an AND operation. Already I said it requires the two operands. For example, here I given one variable a, its value is 5. Here 5 is nothing but it is a decimal value. So first convert the decimal value into binary form. So the value of 5 is, the binary value of 5 is 010. Correct? Next, the value of b is, I assigned 3. So the binary value of decimal number 3 is 11. That means 0011. Now I am going to apply the AND operation on these two numbers. So here I written a equal to 0101, b equal to 0011. So now I applied the AND operation at bit level. So already I said in the first case, all of you observe the rightmost bit of A is 1 and the rightmost bit of B is 1. So here both gives the positive 1 1. So the result will be 1. It is an AND operator. So here the both bits are true. So the output obviously true. All of you observe the second rightmost bit of A is 0. Second rightmost bit B is 1. So one is false, second one is true. Then it is AND operation. The result will be 0. Okay. So if both conditions are true, then only the output will be 1 in the AND operation. So that is the rule. Okay. So similarly, apply the same AND operation for third bit, rightmost third bit from right to left. So rightmost third bit of A is 1, rightmost third bit of B is 0. 0 and 1. The first condition is true, the second condition is false. Then the output will be 0. We are applying the logical AND operator. So in logical AND operator, two conditions must be true. Then only it gives the true value. So in this way we can apply the logical bitwise AND operator on bits. Convert the given decimal number into bits, then apply the AND operation. AND is nothing but the conditions, both conditions will be true. Is it right? Are you understanding? Give reply, anyone? Students, it is clear? Bitwise AND operator. Okay, very good. So next. Next one is the bitwise OR operator. What is the logic of OR operator? Already yesterday we seen the logical is nothing but either of the condition is true, then the out will becomes true. So same example here I written a value will be 5, that is converted into decimal, and b value is given 3, that is 3 is a decimal number, that is converted into a binary value. Binary value of 3 is 0011. So now I am applying the bitwise OR operator on these two variables. So what is the logic here? Either of the condition is true. For example, here the condition is A. The rightmost first bit is 1. 1 means that is true. Condition is true. Then let us take the rightmost first bit of B. That is also 1. If the two conditions are true, then it gives a true only in case of logical operator. So in second one, consider the second bit of A, that is 0. Consider the second bit of B, that is 1. So here one condition is true, then the out will also be true. Why? Because it is a logical OR operator. So next, consider the third bit also. It is true and false. Obviously it gives a true value. It gives a false value when two conditions are false. In the last case, leftmost bit of A is 0, leftmost first bit of B is 0, 0, 0, false, false become, the result will be false. So here we applied the logical OR operator on data A and B. So like this we can perform the logical OR operation on bits for manipulating the data. Next, XOR operator. XOR means, what is XOR? When the out will become true in XOR case. Anyone can give reply? Okay, okay. It's almost 99. Now it is okay, Amma? Yes, if both conditions are different, then the output will be true. Same here. Let us convert it into binary and compare the values. In the first condition, A value rightmost bit is 1, B rightmost bit is 1, both are same, then the output will be 0. Both conditions are different, then it gives the true value. Okay, it is clear. Next, complementary operator, complement operator. It is gives the invert value of each bit. Complements, it is invert value of each bit. It gives invert value of each bit. Okay, for example, here I given one variable A, its value is 10. So its binary number is 0101. So the complement of A is opposite of 1, 0. 0 means 1. Okay, that is the bitwise OR operator. Sorry, bitwise NOT operator. Next one is the bitwise shift operator. There are two shift operators are there. Already we used these two operators already. So one is the left shift operator and right shift operator. Okay. Suppose here I written one expression B equal to a left shift of 2. What is the meaning of this expression, ma? We are going to shift the bits, 2 bits to the left. We are going to shift of A by 2 bits left. So here A value will be 5. So its binary number is 010. Okay, I am going to shift 2 bits to the left. What is the value? What is the output? 0 1 0 0. Here the two bits nothing but 0 1 will be shifted to the left, then the leftmost bit will be 0 and leftmost second bit will be 1. Here leftmost the third bit of A will be first bit and the first bit of A will be second bit, leftmost second bit of B result. Then the remaining two places will be replaced with 0 0. Here we shifted A bits 0 1 because here in the expression given shift the value of A by 2 bits. So the value of A is nothing but convert 5 into binary form, then shift 2 bits to the left. What are the 2 bits here? We are shifting left means 0 and 1 will be shifted, then the third bit will be the first bit of result and second bit of fourth rightmost first bit will be the second left bit of result. So then the remaining 2 bits will be replaced with 0 0. Okay, this is the left shift operator. Similarly, right shift. So in right shift also, here each bit will be shifted to the right. So here I given one expression B equal to A right shift of 2. Here I am representing B equal to A left shift of right shift of 2 means I am going to shift the 2 bits of A to the right. So A is initialized with 5, that is decimal number, and it is converted into binary 0 1 0 0 1 0 and B is the resultant variable. So I am going to shift the 2 bits to the right. So here the rightmost first bit and rightmost second bit will be shifted to the right. Then the third bit of A will becomes rightmost first bit of result and the leftmost bit of A will become second rightmost bit of B. So the remaining two places of resultant will be replaced with 0 0. This is the right shift operation. So bitwise operators are used to manipulate data at bit level for testing. These are the bitwise operators, bitwise AND or complementary and left shift right shift. These are the bitwise operators. Already we discussed all these operators in C language, just we revised today and yesterday. Now we are going to see the operators in C++. Already we discussed operators in C++ are arithmetic, logical, comparison operator, assignment operators and bitwise operators. These are common in C and C++. Okay. Next we are going to discuss the scope resolution operator which is introduced in C++ language, that is represented by : symbol. The purpose of this scope resolution operator is we can access the global version of data, but that is not possible in C language. We cannot access the global value inside of a block. Okay. So line feed operator, field width operator, scope resolution operator and two more operators are there. Those are used to allocate the memory dynamically. So generally we will use the malloc, calloc for allocating the memory dynamically in C language. Similarly in C++ we have new and delete operators to allocate memory dynamically. Okay. Now today we will discuss these are the three extra operators that are added in C++. First we will see the scope resolution operator. Okay, scope resolution operator is nothing but we can access the global version of data which cannot be accessed from within inner block. Okay, in C language that is not possible to access the global data, that is resolved in C++ by introducing a new operator. So that is represented with a symbol of : so that is used to access the global data. Sir. అయ్యో సార్ ఇది 100 పెట్టాను నేను అయినా రావట్లేదా So now we are going to discuss the one of the most important operator in C++, that is introduced in C++, that is the scope resolution operator that is used to access the global data that is not possible in C language. See here one example. Consider here I am using the same variable x in two different locations, two different scopes. Here the x variable is declared in a local to the main, local block. The variable that is declared within a block is called as local variable. So here x is a local variable and the same variable is used in the global also. I declared here I use two variables to do two different scopes. One is the local, second one is the global. Okay. So here if you print the value of x, then see here second value, if you print the value, so it is clear ma? Are you understood this concept, scope resolution operator that is introduced in C++ for accessing the global version of data? It is clear this example? Say yes or no. Can I move to the next slide? Okay, very good. So we will see one more example by using scope resolution operator here. See here the variable x is declared and initialized in three places. First I declared the same variable x in the global above the main, and inside of main also I declared and initialized with a different value x equal 20, and in the above global x equal to 10, and one more I declared within a block x value will be 30. Global value is 10, local value is 20. Again within a block I initialized declared x with a value of 30. So here I am going to print the value of x, sorry, value of k. Here int k equal to x means what is the value is assigned to k ma? What is the value of k here? X means which value it will take, either 10 or 20. Which value is initialized to the variable x here, 20 or 10? Can anyone tell what is the value of k? Please respond in chat box. Okay, 20. Okay, that's very good. So we declared this x is a local to the main, so that's why k will be initialized with 20. Very good. Next, so what is the output of the first cout statement? K value will be 20. Then what is the x value here, 20 or 30? Second output statement, x value To access the global data within a block, but here in C++ we can access the global data by using scope resolution operator. Okay, very good. So already this is also completed. Okay, next one more operator is there. Operators, these are nothing but manipulators. Manipulators are introduced in C++. Manipulators that are used to format operator. You should have to include manip.h in your code. The header file should be included in your code. Okay. Suppose if you write how you evaluated, whether you evaluated from left to right, right to left. God mass. Okay, okay. But here we will follow some rules to evaluate an expression. Suppose the expression will be given without any parenthesis, we can execute in two ways. It may be left to right or right to left. Okay. In some expressions we can get, but for evaluation purpose we need to follow rules. We have to see the precedency of operators. Which operator has the precedency? In this expression we have two operators, minus and star multiplication. Suppose if you evaluate from left to right, means what is the value? 17 minus 8, 9. 9 into 2, 18. So the output will be 18 in case of left to right evaluation. Suppose if you evaluate, sorry, right to left, then 18 to 2, 16. 17 minus 16 means 1. We are getting two outputs for this expression, 17 and one more 1, which is right here. So here we need to apply the precedency of operators if an expression is given without any parenthesis. Okay. So which operator has the highest precedency? Which operator has the highest precedency? So here table is given the precedency of all the operators. So here exclamator and unary minus has the highest precedency, then followed by multiplication, division, and modular, then plus and minus binary operators, followed by shorthand assignment operators, okay, and bitwise operators. The bitwise operator has the lowest precedency than these operators. Okay, now this is the precedency of operators. Suppose if I give one expression, it contains same precedency, then how can you evaluate? Let us see one example. Here I written 3 star 8 division 4 modular 4 into 5. How can you evaluate what is the value of this expression? Eight, then followed by division, modular 4, then multiply with 5. Okay. If the expression contains different operators, then we have to see the precedency of operators. If the expression contains the same operators, then we have to see the associativity of the operators. I think understood. It is clear, ma? The first case, in the first case, here the two operators are there. So here the star operator has high precedency than minus. Then we applied precedency rules, then we calculated. But in case of the expression contains two operators, same. Okay, here the two operators have the same precedency. Then we apply the associativity. We have to see the associativity of all the operators if the expression contains same precedency operators. Okay, I think it is clear, right? Say yes or no. Voice is breaking. Very good. So this is a table you have to note it down. I'll forward the PPT also. Next one is the type conversion. What is the type conversion? Converting type of variable from numeric data type to some other data type. Okay. Whenever the compiler encounters an expression, it divides the given expression into sub-expressions. Okay. Suppose if the condition or if the expression contains two operands, or it may be binary addition operator, or it may be binary multiplication operator. If the operands types differ, means suppose if I given one expression c equal to a plus b and the type of a is integer and the type of b is floating point, let us consider if the type of operands is different, then the compiler convert one of them to match the other. Six, that is a floating type of value. So here I perform the multiplication operation. What is the y here, man? Actually y is float type. Y is a float data type that will store the result of these two variables a and x. Okay, that is automatically converted float. The result is float value that is stored in the y. So now we are going to forcefully convert one data type into another data type. That is nothing but typecasting or explicit type conversion. So we will follow some syntax while converting here. This is the syntax. So here first we should have to specify the data type which we are going to convert, then followed by variable name. This is the one way. Or You can also specify data type and then followed by within a variable name in a brackets. So here I written one example. There are two ways to specify the explicit conversion. So I am going to convert integer type of data into character type of data here. There are two representations are there. We can use any one. This is syntax of type conversion explicitly. Explicitly means we are forcefully converting one data type into another data type. So here 90 is nothing but that is the ASCII value of X character. So the output of this statement is, what is the output here? Can anyone type in chat box? So here we are converting integer data type into character. Can anyone tell the value of X in chat box? I initialized with K 90. Then what is the output? What is the type conversion, ma? What is the type conversion? Character of char of X. What is the output? 90. You are telling. Char. Char means. What is the character? I given already 90. ASCII value of 90. Which character has 90? Into 2 char. Converting from integer to character. So 90 is nothing but here. X. Capital X will be printed 2 times. I use the 2 syntaxes. Okay, it is clear. So one more, you should have to note one point here. When you are converting some higher data type to lower data type, then there is a chance we can miss the decimal values. Okay, when we are converting integer type of data to character or log double to integer, then we will miss some decimal points. We will lose some data. So one more example is given. Converting integer to character type of data. Here I declared one variable with the 97. So here I applied the plus plus x. What is the plus plus x here? Which operator? Increment or decrement? Pre-increment or post-increment? Pre-increment operator. Okay. So we applied the pre-increment operator of x. So this is the output. So here one more example is given. I given here the input is y, value of y is its symbol. So symbols also have the ASCII values. Okay, I given input character type of data and converting explicitly character to integer type int of x. It will return the integer value. So what is the ASCII value of a? 65. That will be printed. Here given multiplication symbol that gives the ASCII value 42. The symbol multiplication its value is 42. Okay. These are the operators in C++. Do you want to note down anything? Any points?
Ma, do you have any questions, Ma? Please, if at all you have any questions, put it in the chat box. Any questions regarding what has gone by? We'll send the material, Ma. Don't worry about the material. We'll send the material to your CR's mail ID. Uh, the CRs can put their mail IDs in the chat box.
Mention the section also, ma. Section wise. Okay.
Ma, whenever you're converting a float into an integer, there is some data loss, ma. So whenever you're working with implicit conversion, there would it would be automatically done by the compiler. Shankar, there would be data loss, Shankar. Try to convert an integer into a float. You have to go with some bigger data types then. So usually, if at all you have written, maybe you're trying to convert a float into an integer. So you want that. I didn't get you, Janvi.
After 10 minutes, we will start the quiz. Do you have any questions? Please post in the chat box. Okay. Yes, we will send the PPT to your class CRs. For sending PPT, we need CR's mail IDs. Okay.